Hello, everyone. Warm welcome for everyone who's joining this online meetup. And thank you to Carlos and rest of the team for making this event happen. If you guys missed my introduction, I'm Karthik. I work as developer relations lead at DGraph Labs. And all throughout this talk, we're going to learn more about what DGraph is all about. So this talk is about how to build GraphQL API functions for Twitter clone just in 10 minutes. And we'll see how using dgraph, just by composing a GraphQL schema file, we can automatically get all the GraphQL API functions, the correct GraphQL API functions which are necessary, are using which you could build a Twitter clone on your own. So let's just get started. Firstly, who's this talk for? If you are one among those who want to get started with GraphQL in minutes and don't want to worry much about server side, this talk is definitely for you. And having said that, it's not just important to get started fast or getting started in an easy way, but it's also you might be concerned about the scalability and performance of your GraphQL API as your application grows and your application becomes more complex. We'll address that too, and we'll see how dgraph solves all of these challenges. So I guess like now, most of the viewers are familiar with GraphQL schema. So a GraphQL schema essentially represents a graph. So next time when you look at a GraphQL schema, do remember that what you're looking at is a graph. And a GraphQL schema represents your application data graph. Let's learn a bit more about how a GraphQL schema represents a graph, and let's do a live exercise. So let's just compose a GraphQL schema for a tweet. Um, and this is how, in general, this is an approach which you could use in general to compose GraphQL schema for your UIs. And this exercise kind of gives you a streamlined approach towards composing the GraphQL schema, even for the most complex UIs. So let's look at this UI. We all are familiar with this. This is the UI for a tweet, and this is a tweet which we just saw a while back when GraphQL Hong Kong meetup was and the announcement was made. And the first step is to identify all the entities in your UI. In this case, we have a Twitter user who's actually sending out the tweet. In this case, GraphQL Hong Kong is a Twitter user. And what other entities do we see here, right? We have the actual tweet, which is the second entity. And we also have @mentions. And @mentions are, again, Twitter users, right? So even the entity who's posting the tweet is also a Twitter user. And also the mentions are, again, Twitter users. So we now have two entities. One is a Twitter user and then the actual tweet. And the third entity could be the hashtags, right? In this tweet, we only see one hashtag. We have two, but in general, you can have any number of hashtags in a tweet. So now we have three entities, namely a GraphQL user, the tweet itself, the Twitter user, the tweet itself, and then we have a hashtag. The next step is to represent all these entities as a node in a graph. So we had three entities, and now we represent all of them as nodes, namely now we have user node, tweet node, and a hashtag node. The next step is to see how these different nodes are related to each other. Do we have a relationship between a user node and a tweet node? If you look at the UI, yes, we definitely have a relationship, right? A Twitter user is the one who actually authors a tweet. So let's represent this relationship using an author's edge from a Twitter user node to a tweet. And next, let's see, like from a UI, is a tweet in any way relates to a Twitter user? It does, right? A tweet can mention a Twitter user. So let's represent this relationship between a tweet and the user a Twitter user using a mentioned edge. So these edges essentially represents the relationships between these nodes. And again, the relationship between a tweet and a hashtag node is can be represented using a tag with edge. So again, quickly, so we started with our UI, and then we have firstly identified all the entities in your UI. We identified three entities. We represented each of the entities as a node, and then we represented the relationship between these entities as edges between these nodes. So the next step is to translate this graph diagram, what we call as an application data graph, uh, to a GraphQL schema. That's relatively easy to do because, as I mentioned earlier, every GraphQL schema essentially represents a graph, the graph of your application data or the data requirements of your UI. So let's see how do we translate this into GraphQL schema. The first step is to represent each of the nodes as types in your GraphQL schema. So we had three nodes, and now we represent or we create GraphQL schema types for each of these nodes. And you could see that we have three types, that is like type user, type tweet, and type hashtag. And the next step is that now we have the templates for all the types corresponding to each of the nodes from our graph. The next step is to represent the relationship or these edges between the nodes. So the way we represent this relationship is by creating a field for your types where the field would refer another type. In this case, you have type user, which refers type tweet via an author edge. So similarly, if you see the type tweet refers back um, a type user via and mentioned edge, right? And the next step, once we have the relationships of represented using the types referring to each other, is to fill in what other fields each of these entities would have and what are its types. For instance, for type user, each user would have a unique ID, which is represented by the GraphQL standard type, the ID type. And then a user would have a username. A Twitter user also would have a user handle, which is a string. And we again have the relationship of a user with a tweet via an authored edge. Then, so after we represent the relationships, the next step is to fill in the fields for each of the types. And similarly, we now fill in the fields for the other types, right? We have uh, a tweet has a unique ID. A tweet also has a tweet message, which is a string. I think in the last slide we missed out on representing the relationship between a tweet and a hashtag. So now we represent that using the tagged with edge. Uh, Now we have the GraphQL schema, right? We started with your application UI, and we arrived at the data graph for your UI, and then we represented the data graph as a GraphQL schema. And what you see now is essentially the representation of all the data requirements for your UI as a GraphQL schema. And the next step is just by using this GraphQL schema file, we're going to auto-generate all the CRUD GraphQL functions necessary to build a Twitter clone or to power all the data requirements of your UI. And let's see how to do that using dgraph. And before we do that, let's understand a bit more about what is dgraph in the first place. dgraph is the world's most advanced graph database, and dgraph is open source. It's a transactional and distributed native graph database. And here is what's exciting for the folks from the GraphQL community. dgraph is the only native GraphQL database which natively interprets and distributes, stores, and executes GraphQL, which means that GraphQL is a first-class citizen for dgraph. And GraphQL is not an additional layer on top of the database. You might have used other database alongside GraphQL by having an additional GraphQL layer on top of the database, which translates the client GraphQL queries into the corresponding database query language. But in case of dgraph, GraphQL is just built in right within the database, and GraphQL is a first-class citizen. So yeah, there's no layering required, and dgraph is also built from ground up to serve GraphQL like workloads. So with dgraph, all you need to know to get started is just GraphQL. We're gonna just see, soon see it in action, wherein we'll take the GraphQL schema file which we composed and just hand it over to dgraph, and dgraph out of the box auto generates all the GraphQL CRUD functions you need. And then as your application evolves, where you need new product features, all you need to do is again come back, edit your GraphQL schema file, and iterate on your APIs. So not just you can get started with GraphQL, you also iterate when using GraphQL. And dgraph, the database admin endpoints are also GraphQL. So which means like all the database operations you can perform using the GraphQL endpoint which dgraph provides. And dgraph is built, every database is built for a very specific kind of workloads. And in case of dgraph, it's built from ground up, it's built from scratch to be able to efficiently serve and scale for graph-like or GraphQL-like or graph traversal-like workloads. So if you are a GraphQL user and if you're building GraphQL applications, the kind of workloads your database would be operating in once you have a lot of client queries coming in because you're using GraphQL in the front end, dgraph efficiently resolves all the data requirements of your UI in one network call in one shot, because that's what it's been built from ground up to serve efficiently and scale for. And okay, let's just see it in action. Let's run dgraph. We are using dgraph standalone container. This is not a recommended way to run dgraph in production, but this is great for quick start purposes. So let's start dgraph. So the database is up, and so this is the GraphQL schema which we just composed, which represents the UI for a tweet. And the next step is to submit this GraphQL schema file using a curl request to dgraph. So let's do that. So this is successful. We just submitted this GraphQL schema file. And now you can use any of your favorite GraphQL editors. We'll use GraphQL Playground. If you're just powering up your GraphQL tool or GraphQL Playground, just point it to http://localhost 8080/GraphQL. So let's just look at the introspection, and you could see that dgraph has auto-generated GraphQL CRUD functions. Now, for each of the types which is submitted to dgraph, dgraph auto-generates 5 GraphQL functions. For instance, corresponding to the type user, we have get user, query user, update, delete and add user auto-generated. And similarly, you can see that corresponding to the type tweet which is submitted, we have get tweet, we have query tweet, we have add tweet, update tweet, and delete tweet. So as I mentioned, for each of the GraphQL type which you submit, dgraph auto-generates 5 GraphQL CRUD functions. So now let's just add some tweet using the mutation. Let me just quickly see. There seems to be an error. Okay, I just see that a value is missing. Let me just quickly grab the mutation from the schema again. We have the mutation. Oops, There seems to be an error. Um, because type tweet requires a value for field author. I think we're just missing. Okay, let's just move forward. I think it's just an issue with the mutation format. And basically, once you submit the schema, dgraph auto generates all the CRUD API functions for you. And then once you have the CRUD functions, let's say you start to iterate on your application, and then you have a new requirement for your app, that is um, to be able to have a search feature for your user handle. Uh, so it's very simple now. All you need to do is just come back to your schema, just edit the schema, and add a simple directive to your schema. In this case, we add @search by hash, and just adding this entry, making this simple edit to your schema, uh, gives you ability to search for users based on the user handle. So just go back to the schema and just make this simple entry. So let's just grab the schema change for user handle and go back to our schema. Let's add this, save the file, and just resubmit um, the schema file to dgraph. Okay, so this is successful. So now, just on adding a simple directive, you would be able to query for the user, right? So you can add a filter to say, hey, by the way, find the user by name Hackintosh Rao and give the user's information, and you can then request for all the tweets the user has authored, and then you can even probably request for the hashtags of those tweets. So have tagged with and then hashtag. And the introspection makes it really easier to be able to get all the auto generation recommendations while you compose your schema or your queries. So let's say now we are able to search for user based on the user handles. How about we that your product now needs a new feature to be able to search for user by user names too? Again, pretty simple. Come back to the schema and just add a new directive search for user by hash. Hash essentially sets an hash index in the database, which allows you to search user by user's name. So let's just do that. So let's just make that simple addition onto our schema. And now let's just resubmit the schema to dgraph. And that's it. You should be able to run a query to search for user based on user's name. Similarly, let's say now you want to search for user just by using user's first name or last name instead of the full name. All you need to do is just again come back and edit your GraphQL schema, right? To change the index for username from hash to term. So this essentially helps you to enables you to search for user based on user's first name or last name or any of the terms in user's name. Need not necessarily use the complete string of the username. So Very simple. Okay, just come back, uh, edit the index, resubmit the schema, and now you should be able to search just by using user's first or last name or any of the term in user's name. And similarly, dgraph offers a variety of indices, and it's very simple. Every time you need to add a new product feature, come back, add a new database index to your GraphQL types, and resubmit it, and dgraph rebuilds the index on the live. There's no need to even restart the server, and you should be able to then use a new more powerful querying facilities. For instance, let's say to power your Twitter search, you want to be able to search using a regular expression. For instance, I'm Karthik Rao. Let's say if you want Karthik Rao to be in your user search, in your Twitter search, even if you use a substring of my name, let's say ART. In such a case, you need regular expression search capabilities. Again, very simple. Just come back, add the regular expression index, save, same process, resubmit, then just come back, and you should be able to run this query, wherein now we are searching just based on a substring in the user's name, and as soon as you type ERT in the search box, that you should be able to get the recommendation of Karthik in the list of users you're searching for. Um, right. So again, with dgraph, as I mentioned, it's not just you can get started with using the database just using GraphQL, but also you can iterate as your product requirements evolves, as your UI requirements evolves, just by using GraphQL. Now, similarly, like we moved on from our last schema to extend the schema to offer new search capabilities. So if you look at type tweet, we've added a full text search for based on the content of the tweet, that is the strings in the tweet itself. And similarly, if you look at hashtag, we added a regular expression based search for hashtags too. So so we just looked at few of the database indices which dgraph offers, and every time you come back, if you want to make use of this database index to power your application feature, you just edit the GraphQL schema file. We saw regular expression, hash. Now we see full text search, and also dgraph offers other advanced indexes like geo search. If you're building a mobile application or a web application which uses location data, which where you want to build queries like find me all the restaurants within 1 kilometer of this location, or within a polygonal structure, it's super easy to do that. And we are adding more powerful capabilities, more powerful indices database, and all you need to do is every time to make use of it is to come back and edit your GraphQL schema file. So um, let's just quickly extend our schema and update our schema with this full-fledged schema. Okay, here we have the full-fledged schema. Um, and now again, just resubmit the schema. And go back to the playground. So now we can do a full text search based on the content of the tweet itself, uh, which was not possible before. And all we had to do to enable this feature is to add a very simple directive to your GraphQL schema. So let's move on, and let's just have a quick recap, right? Now, with dgraph, all we did to obtain the CRUD GraphQL functions is to compose your GraphQL schema. So if you're an app developer, if you're a GraphQL developer building your mobile application or web application, start with your UI, identify the entities, get your application data graph, and convert that into a GraphQL schema. And then that's all you need to get started with dgraph. And dgraph gives you full-fledged um, CRUD GraphQL functions to build your applications, and all of this from just your GraphQL types. Right. Yep. That's all I have for this talk. And please do check out dgraph's website to go visit dgraph.io. And more specifically, if you are interested about learning dgraph's GraphQL capabilities, you can take a look at dgraph.io/GraphQL. Um, and dgraph is open source. Please do feel free to go download and try dgraph. And I think the easiest way for you to be up to date with all the updates from dgraph labs is to follow dgraph labs on Twitter. Please visit at the rate dgraph labs, or you can follow me on Twitter at the rate hack into sh rav. That's hack into rav. That's me. And other two resources are to stay up to date would be to follow dgraph's blog at blog.dgraph.io, and also I think GitHub would be a good place to follow up with all the products development and even the product roadmap. Thank you everyone for your time.